Good afternoon, everyone. I'm Dr. Stephen Liss, the Vice President of Research and Innovation at Ryerson University. We are proud to host this event today about the future of freight and goods delivery. I'd like to begin with our land acknowledgement. We are in the dish with one spoon territory. The dish with one spoon is a treaty between the Anishinaabe, Mississaugas, and Haudenosaunee that bound them to share the territory and protect the land. Subsequent Indigenous nations and peoples, Europeans, and all newcomers have been invited into this treaty in the spirit of peace, friendship, and respect. The land acknowledgement reminds us of the important work of reconciliation that is ongoing, the need to address the historic wrongs, and establishing meaningful and impactful paths forward. As Canada's comprehensive innovation university, Ryerson engages in scholarly research and creative activities that address real-world challenges to drive economic growth and improve the quality of life for Canadians. As an urban university with a mission to advance applied knowledge and research to address societal need, city building is an important part of our DNA, as is innovation and working with industry partners to deliver research that addresses complex problems. Our Smart Freight panel today includes some of our region's foremost experts in transportation, management, logistics, and cybersecurity. They will be discussing current pressing challenges related to urban freight, opportunities to improve the safety, efficiency, and environmental impact of goods delivery in the region, and Ryerson's research partnership with the Smart Freight Center. The Smart Freight Center, a new center of excellence for goods movement, was established in 2019 with seed money from the region of Peel. It is a collaborative network between McMaster University DeGroote School of Business, the University of Toronto Transportation Research Institute, the York University Liaison School of Engineering, and Ryerson University. It is my pleasure to introduce our panel today. Dr. Sabbir Saiyed is one of the founders of the Smart Freight Center with over 25 years of experience in civil engineering, transportation, and management. He is currently the manager of transportation system planning at the regional municipality of Peel. I'm very pleased that three panelists today are Ryerson faculty members and working closely with the Smart Freight Center. Dr. Bilal Farooq is an associate professor of civil engineering and director of the Laboratory of Innovations in Transportation at the university. He holds the Canada Research Chair in Disruptive Transportation Technology and Services. His academic interest in cyber, physical, and transportation systems, artificial intelligence, machine learning, simulation, behavioral modeling, optimization, and active mobility is aimed at discovering innovative solutions to real-world problems in transportation. Dr. Mashatan is an associate professor in the Ted Rogers School of Management and director of the Ryerson Cybersecurity Research Lab at the university. Dr. Mashatan is widely recognized as a leading expert in cryptography, blockchain technology, quantum-resistant solutions, enterprise security architecture, and Internet of Things security. Finally, Dr. Sharareh Taghipour is an associate professor and the director of the Reliability, Risk, and Maintenance Research Lab in the Department of Mechanical Industrial Engineering at Ryerson. She holds the Canada Research Chair in Physical Asset Management, and her work employs stochastic modeling and optimization, reliability engineering, and smart asset management to enhance energy efficiency, advance mechanics, and improve performance outcomes in multiple industries, from medicine to transportation to heavy manufacturing. It is my distinct pleasure to introduce our moderator for today, Carolyn Kim. She's the Ontario Regional Director with the Pembina Institute, Canada's foremost think tank on energy and environmental issues, where she works to advance practical solutions that support a clean and efficient transportation system in Canada. Over to you, Carolyn.
Thanks very much, Stephen, and thanks to the City Building Ryerson for hosting this amazing event today. At Pembina, we've been researching freight and goods movement and how we can solve for the growing emissions that we're seeing in Canada. And the reality is, in Canada, freight transport emissions have increased 154% since 1990. And when you look at the total emissions in Canada, 11% of Canada's emissions come from freight transportation. So I'm really pleased to be part of this conversation. So today's presentation will consist of roughly 30 minutes of moderated conversation with our panel. Following this, we'll have 15 to 20 minutes in which we'll answer questions from the audience, and we will promptly end the event at 1 p.m. To submit a question, please use the Q&A function at the bottom of your screen. And just so everyone is aware, we are recording the webinar and it will be posted on the City Building Ryerson's website in the coming days. To kick off our panel discussion, I want to turn to Sabbir. As the founder of the Smart Freight Center, can you just give us a flavor of what the Smart Freight Center is? Why was it established? What does it hope to achieve, and who is a part of it?
Thank you, Carolyn, and welcome everyone. I'm very pleased to be here. Smart Freight Center, as Stephen mentioned, is an excellent collaborative partnership between 4 universities: Ryerson University, University of Toronto, York and McMaster, and Region of Peel. And when we provided the seed funding for the Smart Freight Center, we at the Region of Peel, I will provide you some statistics in a minute. But as we all know, the goods movement knows no boundary. It is important to have that greater collaborations and partnerships. And as Carolyn, as you mentioned, the GHG emissions are rising. And especially the transportation sector is one of the contributor as well. So for the Smart Freight Center, we are proposing a center, a goods movement center of excellence, where the universities, the industry, and the private sector partners are participating to provide and ensure the safe and efficient movement of goods. And as we all know, traffic congestion has been identified as #1 issue in Greater Toronto Hamilton area, as well as in Region of Peel. And it is very important to ensure that we are working all together. And we especially chose the universities for one reason, that universities are at arm's length from the government. They are providing that evidence-based, unbiased report and the research that all the goods movement industry and the partners can work together. Just to give you some statistics, in Region of Peel, $1.8 billion of goods move through Peel every single day. Toronto Pearson International Airport, which is located in Region of Peel in Greater Toronto area, handles more air cargo than the Vancouver and Montreal airport combined. CN's Brampton Intermodal Terminal is the largest terminal in the entire country, and it's contributing, handling more than 60% of CN's traffic. And goods movement industries contributed 48% of all the industrial and commercial taxes in Peel. So you can see why the goods movement industry is very important. And just let us look at the statistics for Canada. Canada imports $6 billion of fresh fruit every single day. And the top 3 products are grapes, bananas, and strawberries by value. And I must say that the blueberries continues to be the top export from Canada. And how we transport these goods, that's very extremely important. And that's where the Smart Freight Center will help us to make sure that we are providing that safe and efficient movement of people and goods. And I want to thank the trucking professionals during this pandemic and all the goods movement professionals who are making efforts right now to keep us at home safely and provide us all the foods from all over.
Oh, we might have lost Sabbir here, but it's a good place to end. So I'm just going to jump in here because I feel like I'm part of the problem. I'm eating all the strawberries, bananas, and blueberries here. You know, Sabbir has really laid out the immensity of the challenge here and the demand for goods movement in the region. and the importance of research, the important role of academic institutions. So I'm going to pass it over to Adi and Sharareh to talk about what, when it comes to improving freight and delivery systems, what are the key issues that are involved and what research is necessary at this point? Over to you, Adi, first.
Great. So thank you for the question. And it's great to be here to share some of the concerns I have for making everything smart and how I can help with mitigating some of the risks. So whenever we call anything smart, it means that we are empowering it with digitization. And if you're making a lot of data accessible to end users, which is a great thing, but also to attackers. So I come in from a cybersecurity perspective and find this kind of a concern that these little devices, such as Internet of Things, sensors that we put on everything from trucks to sensors to packages to homes to offices to streets, are carrying a lot of sensitive information, which are very important for us to gather and to make sure that the systems that we are designing and operating are actually useful and reliable and accessible. But that comes with a compromise of having all of that data accessible at the fingertips of an attacker if we don't do it carefully. So let's go back to the pillars of cybersecurity. We look at confidentiality, integrity, availability, authenticity, and accountability of our information systems. And smart freight systems are not going to be any exception. So we need to look at what needs to be kept confidential, what needs to be kept in integrity of that data needs to be ensured, what systems are, we need them to be available because we don't want an attacker to come and completely disrupt our operations and bring them down in a denial of service, for instance. Authenticity of users, operators of those trucks, and all of the different stakeholders playing in this ecosystem, and accountability of everybody. That has something to do with the goods, with the transportation, anything that they're dealing with. So cybersecurity helps with all of those. So, and these are not problems that we just discovered yesterday. So your question could be, well, we should have by now figured all of this out, right? So cybersecurity is a discipline that was created and has been advanced for quite some time by national security agencies, by regulated industries such as banks, and that's true. However, cybersecurity is very contextual. The kind of attack scenarios or adversarial models that we have for a bank is very different from that of a smart freight center. So we need to study all of these systems all over again to make sure we understand the adversarial models and what is actually sensitive in terms of its confidentiality and integrity and availability that we want to protect. And there's always a balance between usability, accessibility on one side, and reliability and security on the other side. We can really lock down our systems in a smart freight system so that they're completely secure, but not that usable. Where do we draw that line? So this is a very research-intensive question that we hope to be able to answer in the work that we do in this area. Study specific use cases and understand exactly what this context is. Where do we want to draw that line between usability and security? And in general, answer this question that what does cyber resilience of smart freight IoT Internet of Things really mean? It's not a one-size-fits-all approach because a lot of these devices are very constrained. A lot of the sensors we put on the goods are very constrained. Their memory is not that big. Their power, the batteries on them are not that big. So if you use the same cybersecurity mechanisms and tools that we use for an iPhone or for a server or for a laptop, it's not going to be anything that we want out of these small IoT devices. So some of these fundamental components need to be redesigned from scratch, understanding the actual constraints that these devices have in the context of smart IoT center. So I think this is a very key point to understand the context and to perhaps reinvent some of the cybersecurity measures to ensure that we have confidentiality, integrity, availability of the data, which leads to the reliability of smart flight centers.
So no shortage of questions there, a lot to unpack. You've raised a lot of really important questions there. But Dr. Taghipour, you bring a different lens to the table, and I'm curious to hear from your perspective and your discipline in mechanical and industrial engineering, what you see are the most fundamental questions here that we need to answer.
Yeah, sure. Yes. First of all, hello, everyone, and thank you very much for attending the webinar today. So you asked about the certain problem that in fact, the freight and the delivery system are dealing with. Like there are definitely certain challenges, and I think one of the most important one might be the in fact invisibility of supply chain, because like whenever the cargo leaves the source and goes to destination, it may meet several agents, but it's not very easy to actually track them and see where they are going, and that causes a lot of other problems. For example, fraud may happen, and we may have lost goods in between. And while that we have several challenges, I would like to kind of a little bit draw the attention to the challenges that maybe I'm like dealing with in my research and I could potentially help with, and that would be more on the operational aspect of the delivery system management, and that has direct impact on the in fact the delay that like the customer at the end, because when the customer, they are not receiving what they are supposed to receive on the right time, and also like in a good shape that is supposed to do, and so at the end it would be unsatisfaction of customer, and at the same time would be lost to the businesses, and also negative impact on the environment and overall sustainability. So, so I think what that aspect of that, like something that we can actually do, we can actually work with the data available and operational data available, and that data, because when we are dealing with the delivery system, we are looking at the different transportation mode, and also the truck, the vehicle, or whatever actually transferring the good. When you have data available for both sides, means that the mode and also the vehicles involved or fleet involved, and then you look at the historical data, we do some prediction, we establish certain analytical model, and to see how the demand may look like, and also how the status of those transportation modes look like on daily basis. We can take all of those into account and establish certain model for prediction, and using those prediction in hand, we can actually optimize things. Means that we can decide daily, for example, which fleet or which vehicle in a fleet should do certain job and deliver the thing from which path, from which route, and all of them can help that at the end we can deliver what is supposed to be delivered to customers on time, like not with delay and in a good shape, but with minimum cost, at the same time with minimum impact on environment, because like for delivering we need to consume energy is directly translated into CO2, so it has all of those impacts. So my research mainly would be helping with those operational excellence and how using related data actually we can make better decisions. And like for that decision making also can be done in fact in two modes. One of them is more like a offline mode, what we call it, means that we have the data, we come up with the decision, we plan for it and it's implemented. Another would be that in real time, means that we start with an initial plan, but whenever something happens, for example, if we have a priority, some goods should be should be delivered like without before prior plan, and then how the thing that need to be changed again in real time in order to make it happen. So like these two aspects more on data analysis and optimization part, these are my area that actually I can assist with.
All right, wonderful. Thanks so much for that. Also a lot of considerations when it comes to operating, finding operational efficiencies, taking data to find new insights and continuing to find efficiencies. We heard a lot about data. I think the past two speakers talked about using data to make improvements, but there's a lot of considerations when it comes to that. Bilal, I want to turn to you now because you know, Sharareh and Adi have talked a lot about some of the innovations that, you know, they're looking at. From your perspective, what are the top innovations that engineers are looking at to bring about safety, a safer, greener, and more efficient goods delivery? And before you answer, I just want to remind the audience to type in your questions here, you know, as the speakers are kind of sharing their perspectives. Pop them in the Q&A and we'll get to it shortly. So over to you, Bilal.
Thank you very much. First of all, thanks a lot to CBR, City Building Ryerson, for organizing this cafe. I always enjoy these cafes whenever they organize. And thanks to the audience as well, and our Smart Freight Center itself. So to answer your question, I mean, as a transportation engineer, I think I'm living the best career of any transportation engineering researcher throughout the past 100 years or so, because there's so much disruption that is here that is happening in transportation systems, and those disruptions, they have effect on the transportation network, on our behavior, on our environment, and so many ripple effects that are going on. Particularly if you look at the disruption that is caused by the connectivity that happened on passenger traffic side, that's well established, but now that is bringing a lot of disruption in the goods movement side as well. Particularly if you look at this past year or so when we had the pandemic, and in this the last mile goods delivery has changed so much. I mean, I haven't been to a grocery store since more than a year now because I can order it by my app, and all sorts of last mile deliveries, they are happening through connectivity. There is a big role of automation that is coming in. There are companies that are trying to produce self-driving cars, but they are very soon realizing and tweeting about the fact that it's a very difficult problem. Yes, it is a very difficult problem, but automation has a strong role in freight, especially in terms of their operations on highways. Highways where there are uninterrupted flows, the automation connectivity can form these platoons of trucks that can actually work in a more efficient way, whether it's in terms of energy efficiency, whether it's in terms of the delivery and so on. So there is a lot of disruption that is happening through automation. Then the electrification dimension that is coming in. So connectivity, automation, and electrification. These three are the key disruptions that need to be very actively studied, especially in the freight context. At the same time, we have introduction of these urban air mobility concepts. For a long time, it was for a very niche sort of passenger movement, but now it is becoming mainstream. There are companies who are operating drones, operating these drones that can deliver from various fulfillment centers to the actual delivery point. So all these dimensions are such that they need to be studied, and they need to be studied in an integrated manner. Not just that, that integration should not just remain in the freight domain. It should move towards the integration with the passenger domain as well. One thing that is very challenging and kind of artificial is that we have a very distinct divide between passenger mobility research and freight mobility research. I think in the end, passengers and freights, they are using the same transportation network, and integrating and studying them in an integrated manner, that is extremely important. So these are the areas that I focus on, and I try to develop the underlying intelligence that could result in operational solutions for freight and passenger movement.
Indeed, freight and goods movement presents an interdisciplinary challenge, and it requires looking at land use, transportation, infrastructure, our clean energy system here in Canada. Sabbir, I want to go to you. We've heard a lot of the challenge here, a lot of the opportunities and also the challenges, but from your perspective, and you shared a little bit of this in your opening remarks, but what are some of the obstacles and barriers we face to implementing a better freight system now? And if you can also kind of speak to, from a data standpoint, in terms of like logistics and technology, like how can we leverage these new tools, this new kind of collection of data to help with that? So let's start there. How do we make sure that we get our vegetables, our fruits, but also kind of minimize our environmental impact?
Yeah, so Carolyn, I think that's an excellent question. I think one of the things that we were just discussing when Professor Bilal Farooq mentioned that customers' expectations are growing. And we have seen that we are changing our travel pattern. And there's an increasing concern of the effects of traffic congestion as well. And as you mentioned earlier, that there are emissions from the transportation sector, which are very important, and the coming of automation and the technological changes and the robotics that are coming up soon. So, and
looks like we might have lost Sabbir again. I'm just going to give him one more second to see if he can reconnect. And then I will, there we go.
We are partnering with the universities because the research data and the evidence-based decision making is extremely important. So the robust, secure data collection, monitoring of all freight modes, understanding the goods movement pattern, evidence-based analysis, those are very, very important from a municipal perspective. And as a municipality, we want to make sure that we are providing those transportation infrastructures. We are providing and facilitating the last mile that Professor Bilal Farooq mentioned, and how we can improve the quality of life of our residents and how can we improve the environment. Those are the key of the things that we want to make sure. And from the Smart Freight Center, we want to facilitate the data warehouse. We want to make sure that the data is available not only from the public sector, but as well as from the private sector partners as well. So we want to facilitate the partnerships, the advocacy, the engagement, and the awareness in the goods movement sector.
Okay, so we heard it from Sabbir. He's creating this data warehouse where everybody's going to have all the information that they need. Bilal, can you speak to, you have all the data you need, what's the research, what's the innovation that you want to address? I know you named a few, but name the top two or the top one that's that you'd like to pursue in the next year or so.
Well, so given that my core goal is to look at the issues like congestion, greenhouse gas emissions, safety side. So how can we create alternative solutions, alternative mechanisms that can address these issues in a way that we are not actually creating new issues. And in that context, I think that this last mile delivery, it is a very important problem, and last mile on demand delivery I'm talking about, in the sense that we are going to start doing our on-demand grocery, keep on doing even after pandemic, or Uber Eat, or all these different apps that are there. We are going to keep utilizing them, but at the same time, if we keep on utilizing them, and they would keep on generating more congestion on our road. So we need to look at from congestion, the greenhouse gas emissions itself. So we need to look at alternative solutions, and we need to look at the role of connectivity and automation, and also the role of this urban air mobility. So in this context, I'm going to be looking at how can we develop multimodal, these automated on-demand solutions that can take advantage of technologies like drones, technologies like sidewalk robots, and develop a system that can provide these on-demand last-mile delivery in such a way that we are not bringing more cars on the network, we are not creating more greenhouse gas emissions, we are keeping the air quality better, and at the same time providing a level of service that is better than existing solutions. So these technologies are such that they are not science fiction. We have currently, you may have noted in downtown Toronto, there's this orange small box that keeps on running on the sidewalks called Tiny Mile, or no, I think it's called Jeffrey, and the company is called Tiny Mile. So these sort of solutions are already been tested. So my role is to develop the underlying intelligence, whether it is in terms of matching, whether it is in terms of routing, whether it is in terms of consolidation, to come up with a system that is fulfilling multiple objectives, both on the consumer side, environment side, and on the transportation network side.
Great, thanks. You talked a lot about the disruptive technologies there. Drones, also something that's being discussed and a little bit contentious. Adi, I'm wondering if you can kind of also offer your perspectives on research and the top innovation that's happening on, and if you want to respond to Bilal's comments on the opportunities of using drones, like from your perspective on cybersecurity, do you have anything to add there?
I'm not a drone expert, but my brother makes drones, so I'm in a conflict of interest. I'm not going to badmouth drones. But from a cybersecurity perspective, I think there are a lot of challenges, but also opportunities, right? So you hear these, sentences, phrases, mottos in the industry that data is the new oil, and data is the new gold, and then data is the new currency. For something like smart freight, data is really valuable. So we actually want to have all of that data accessible to people who are designing these systems and to the end users, to be able to react to the data and make the system more efficient, more timely, more to make macro and micro optimizations, right? So the challenge becomes that whenever you have a system that smart with that much data available, it's a double-edged sword, right? So as I said, it's available to you, but it's also available to the attacker. So some of I saw there was a question in the Q&A, so I take advantage of that and respond to that question as well. So some of the emerging threats and also current threats are for smart freight, we're already considering in other scenarios, but the way, and I'm going to specify a couple examples to substantiate it, but the problem with smart freight is that, or not the problem, the challenge that we need to solve from our research perspective is that the context here is very different, okay? So I give you a specific example. The devices that you put in a car that is being designed right now are going to be on the road for the next 20 years. And in 10 years, with 20% probability, we will have, and 20% is really a high probability from a cybersecurity risk management perspective. In 20 years, in 10 years, with 20% probability, we will have a quantum computer scalable enough to hack into the current cybersecurity measures that we have, specifically public key cryptography, RSA, and ECC that are standardized with the current standards using, we use them in our cell phones, we use them in our laptops, we use them whenever we, connect to any HTTPS or, credit card security everywhere. The problem here is that when you put a security measure like that in a car, you don't get to go and change it in the next 2 years. You have access to your laptops don't live that long. You know, maybe in 5 years, this laptop is archaic. Who cares about the fact that it's using old cybersecurity measures? But a car, a truck is going to be on the roads in the next 20 years. So what is being designed right now is going to be in manufacturing on the road, set on the road next 5 years. And in 20 years, it's going to be out there. Now, 20% of a quantum computer attacking the security system in that truck is a big problem. And that's an emerging problem. So in some cybersecurity scenarios, this is an easier solution to deal with, because you're dealing with big servers that can handle the new standard that is coming out by NIST, National Institute for Standards and Technology. But when you have a small sensor, it's already at its capacity running the current system, let alone quantum resistant systems, right? So what is that we can do? Can we design specific systems that are quantum resistant for these small devices and then put them in these trucks that are being designed for right now? That's a big research problem. Another topic that I'd like to talk about is the distributed nature of everything in smart freight. Okay, so when you're dealing with an enterprise, like an office scenario, you can imagine, or when you're in a bank, when you're in a hospital, in any company, the number of people you're dealing with is, you know, much smaller set of users, players, participants. And when you have a system as complex and as big as smart freight, all of these people who are delivering stuff, all of the manufacturers and all the end users, it's very difficult to make sure that we have the same level of control, to have a trusted third party, to have a public key infrastructure that sits on top of everything. So this distributed nature of it is very difficult. It gives you a lot of opportunities, but it also provides a lot of challenges from an IT security perspective. So you might have heard about blockchain technology or distributed ledger technologies in general. They're coming to rescue in terms of verifiable credentials. So you don't have a trusted third party that issues the credentials of employees and enterprise, but you can have distributed ledger technologies providing you with verifiable credentials. Now, this is really cutting edge research even in enterprises right now. So we're working on standards of verifiable credentials or verifiable processes. We want to do that with the lens of smart freight as well, because it would have its nuances and it would have its considerations, because it's a very specific context, as I said. So this is another example of a cutting edge research topic for smart freight.
Wow, that's a lot to digest, and I feel nervous now. I feel there's a lot to consider here, because everybody's connected. Everybody has a smartphone. Everybody is in businesses, in order to grow and to be forward thinking, they have to have their vehicles connected to their IT systems, telecommunications. So there's a lot to digest, and there is a question from the audience about cybersecurity, but let's kind of like change gears a little bit, because Bilal, you mentioned the use of cargo bikes, or the Tiny Mile, a company called Tiny Mile. And we are seeing in our streets the use of cargo bikes to deliver goods. And so there's a question from the audience here that kind of is asking about, what do you see the role of micro hubs and cargo bikes in sustainable freight in Canada? We know we're seeing a lot of examples in Europe, in the States, but what's the opportunity here in Canada? And what do you see are some of the issues? And I'm going to pass it over to you, and then I'll make a few comments at the end regarding our research here, but over to you.
Great. I think it's a very promising technology, and especially in terms of the the emissions that we can reduce in dense urban areas. But at the same time, we have to be cognizant of the issues that can come in. First of all, Canadian urban areas, for there to operate year long, in winter, in snow, and all sorts of conditions with these sort of bikes, that is something that is a challenge. It may not be feasible everywhere. At the same time, we have to be cognizant of the existing cycling network capacity. We have already made progress in terms of increasing our cycling network, the capacity of it, and especially making sure that it is going from somewhere to somewhere rather than just a couple of blocks and so on, and it's a very connected network. But if you look at these sort of bikes, especially cargo bikes, they are taking much more space than a normal bike. So making sure that we have the existing capacity that can accommodate these bikes without any safety concerns, without any, well, we are not there yet, but just like what is happening in the Netherlands, that you have congestion on bike lanes. So those sort of issues are something that we would need to consider. But in terms of the environmental dimension, the sustainability dimension, I think it has a great potential. We just need to make sure that the underlying network is able to provide the required capacity for it.
Thanks very much. And Sharareh, I'd love to hear your perspective, because whether it's a truck or a cargo bike, there is still the issue of operational, best practices and issues of optimizing routing, so that businesses can see that efficiency from a cost or operations perspective. Do you have any thoughts here about how this can work successfully in Canada?
Yeah, I have, again, if I want to come back to my own research, if Canada wants to do something, I think first you have to see what is the current status there, what kind of system they are in there, and whether the data is really available to us, whether even, because as far as I know, the majority of work might be done just manually and they are paperwork. So we have to first see what we are, and then if we are not there, not yet digitalized, so the digitalization needs to be done before really going to automation, I think. So if I want to do something, first I would look at the possibility of data. If the data at least is available in some way, even not in real time, I would like to look at them. And if I want to do something perhaps which is more related to my research area, I look at the reliability and perhaps the improvement of the, let's say, reliability of the fleet, and to have some prediction for them and decide, for example, which one need to be sent for repair, because if the trucks and if the transportation mode is not available, so they cannot participate in delivering of the goods. And also again, for the optimization of, for example, the scheduling of the fleet and the operation of them, and optimal path, optimal allocation of the goods to the fleet. So this is what I'm going to do. But if still the technology is not there, so we can still do some work about that, and means that we are again collecting the data, making the decision in offline mode, and then implement them. But if the technology goes to the point that everything becomes available in real time online, then we can go to the real time decision making. And then again, everything that I'm doing, such as, let's say, that reliability prediction can be done in real time. But this is only possible if, for example, truck have some sensor on them, and they can just send the kind of some measurement from the sensor to some center to be analyzed, and based on certain model, we can predict, for example, when a vehicle is about to fail. And then, so by having that information, now we can kind of revise the plan, revise the schedule. And if we have again the real-time information about, let's say, traffic congestion, then we can again replan the road and the path. And so by establishing certain model to decide and then considering the cost and considering the footprint. So I kind of like my contribution would mainly, I mean, based on these two factors, like if the technology still is not there, but certain data is available, we can do something about it. But if the technology is there, which I doubt that we are still not at, probably not and that era of the fully automation and like availability of the data in real time, which if it can go that, of course, a lot of other things can be done and like would be good for like businesses. At the same time, customer would be happy, and we can also have sustainable operation.
Thank you for that. Sabbir, I'm going to go to you next because there's a question from the audience about a specific legislation. It's called the MOMS Act. I've never heard of it, but I think what is the point of this question is the safety of using cargo bikes in separated lanes and where they should safely operate on the road. And as I'm going to ask you to put on your municipal hat now, you know, or the regional hat now, you know, do you have thoughts you want to share about, you know, the safe use of cargo bikes and where they should be operating? Oh, you're on mute, Sabbir.
Yes, Carolyn, that's an excellent question. And this is one of the questions that we want our Smart Fit Center to provide us an answer as well. And as you know, in a municipality like ours, there's a more than 25% trucking activity of Ontario happening in Peel. And many of our regional roads carry more than 10 to 15% heavy truck traffic. And we also receive a lot of suggestions from our residents as well about the increased truck traffic and how it is impacting their lives. And we also want to make sure that there's a safe and efficient movement of people and goods. At the same time, we are also helping our economy as well. So one of the questions that you asked about the cargo bike, that's an excellent question. And we are looking towards the cargo bike. And many of our areas, such as high urban density areas like city of Mississauga, Brampton downtown, there are many areas where we can safely use cargo bike. But one of the issues that we want to study with the Smart Freight Center is that how these bikes can be safely operated on the arterial roads, on the local roads, and on the collector road network, because they have to exist with motorized traffic as well as the non-motorized traffic. So definitely we are looking at cargo bikes in a different way. Obviously, we will have to look at the legislation, the policy making, and we want to make sure that we have enough and sufficient data available to employ the cargo bikes. But definitely this is one area that we can have a Smart Freight Center do additional research. For example, many high density urban areas where we can employ. And there are some legislation requirements that we can definitely employ in this regard. So for us, the safe and efficient movement of people and goods is important. And we are always looking at the new ways as to how we can employ those sustainable modes as well.
Great, thanks. At the Pembina Institute, we've done a little bit of research on the use and viability of microhubs and psychologistics for commercial deliveries. And we did find that there are benefits when it comes to reducing greenhouse gas emissions, and also for the business side, seeing operational efficiencies and cost savings. But of course, it really matters on the context of, you know, and the application of cargo bikes in the local context. And Ontario is currently contemplating policies that regulate the use of cargo bikes, and is looking to launch a pilot that looks at the use of e-cargo bikes for deliveries. So I encourage the audience to check out the policy proposals that are in front of the Ontario government now. Okay, I promised that we would switch back to the issue of cybersecurity because there's a lot of interest here from the audience on that. Adi, I'm wondering if you could speak to something that you mentioned in previous remarks. Some systems would need to be rebuilt from scratch in order to be sufficient from a cybersecurity perspective. And the audience member is looking for some examples of that.
Yeah, so that's a good question. Actually, that's a great question. So in many cryptographic, or generally speaking, cybersecurity solutions that are standardized for regulated industries such as healthcare or finance, the assumption is that the devices have enough capability to run certain mathematical computations such as modular arithmetic, exponentiation in modular arithmetic. And when you're dealing with Internet of Things sensors, so in your Internet of Things, you can have big devices such as servers and iPads and iPhones and even TVs or fridges. You can also have small sensors that you put in a parcel or beside a light fixture or beside a, something that you want to scan. And those devices do not have capability to sustain that level of computation for the life that you want. They may be able to do a few or a week or two, but then the battery runs out. Or they may not even have the memory to do that fast enough, to compute that mathematical function that you want fast enough. So some of those techniques, some of those algorithms need to be redesigned so that these small devices can handle. And it's not just smart freight, actually, it's anywhere in Internet of Things. As we're putting things more on the edge of Internet of Things, these devices that are becoming smarter are collecting more sensitive information about us. And that's a problem anywhere in IoT as we're pushing to the edge and as we're expanding the perimeter of the system with these IoT devices. And it's the IoT information security concern is everywhere, in smart home, in smart offices, smart cities, as well as in smart freight, when we use a lot of IoT devices to make that accessibility and reliability.
Great, thank you for that. I think we have time for one more question from the audience, but it looks like we might have answered all of them. I encourage you to quickly pop one in and we can on the fly answer a question from the audience. I would, just while we wait for one question to line up, Sabbir, and this is a question for everyone. So, whoever wants, just jump right in. We're seeing such momentum on goods movement planning here in the region. And with Ryerson coming on board with the Smart Freight Center, I think it just really strengthens our ability to plan. And I imagine that this will be something that international actors can also look to in terms of outstanding research. I'm just wondering, do you have, Sabbir, as kind of the seed of the Smart Freight Center, what's your vision for the Smart Freight Center, and maybe other panelists can join, 5 years from now, 10 years from now, what do you hope for this kind of coalition to achieve?
Yes, Carolyn, that's an excellent question. So we have this excellent collaboration with universities, public sector and private sector, and we want all levels of government participating and helping the Smart Freight Center. And we are focusing on all modes. And as Sadie mentioned as well, that cybersecurity, the new technology, these are very, very important. We are also here to help all related industries. So shippers, logistics, service providers, manufacturers. Plus our focus is not only the urban areas, but as well as the rural areas. And with the Smart Freight Center, we want to focus on the research data, evidence decision-based making, the partnerships, advocacy, and engagement awareness. And we also want to have this Goods Movement Center of Excellence, where we want to work with all the stakeholders, the private partners, and make sure that we are providing that leading edge research And also we are training the next generations of great planners and engineers. And that's why I'm very, very pleased to have this excellent relationship and partnerships with universities, where universities are providing that unbiased report and the facilities. And I must say that the Smart Freight Center is located at all 4 universities. I'm looking forward to applying for many more grants, and I'm very pleased to let you know that we received an NSERC's over $3 million grant for various projects. And with our faculty here from Ryerson, from all other universities, we want to go into those areas where we haven't done any research, especially in the new data side, technology side. And this is where I think Bilal can and his team can help and to provide that leading edge research partnerships.
Great. Okay, let's do 20 seconds each. Just final remarks on what you hope to achieve together.
I'll jump in. Sabbir mentioned this training dimension, and I think training of the next generation of engineers, planners, and scientists who are ready to work in freight-related issues, freight-related emerging issues. That is our top priority after the research agenda that we have, and we are planning to create venues and courses and programs in that dimension, so that our students, they are well prepared to go into the industry.
Great. Over to you, Addie.
I hope to develop proof of concept implementations and integrate them into the implementation ready package for the Peel region's Smart Freight use case, and also be able to produce robust and practical implementations of provably secure systems, and in return, enhance the contextual privacy and security of the end users of these systems.
All right, and last but not least, the final word. Over to you, Sharareh.
I'm also hoping that we'll actually be able to develop like predictive analytics model and also optimization model in different aspects of the freight and like delivery system. But I should also emphasize on the like collaborative nature of this work, because like, I mean, definitely there are many different key players that they need to work together in order to make it happen. So we're hoping that we can do it at Ryerson and with collaboration with other involving universities.
Wonderful. Well, there you have it, our esteemed panel. Thank you so much for such a lively and a lot of questions that have been raised indeed. So over to you, Charisse, to take us home.
Hi, everyone. I'm Charisse Berta. I'm the Executive Director of City Building Ryerson, hosting this event. And just quickly, I want to thank all of our amazing panelists. I want to thank Carolyn, a wealth of information over at the Pembina Institute, and also at the Smart Freight Center. At City Building Ryerson, we will post a copy of this webinar, this video, and we'll also have some links to Pembina Institute and to the Smart Freight Center. So thanks everybody for taking the time to join us today, and we'll see you again for our next Urban Innovation Cafe.
Thank you very much.
Bye, everyone.
Bye.